we will deal with what we call other printings, and then on next Friday we will deal with heat-set printing and illustrative printing. So now that here let me say an overview on the printing techniques that are covered under the VOC degree. So you see, it's there are a lot of printing activities, and we will go now into detail. But first, that's very important, we have to look on the definitions. What is printing? So as you can see here, printing means any reproduction here of text and or images in which with the use of an image carrier, the ink is transferred onto whatever type of service. So what you see, the service or the type, it doesn't matter. It can be wood, it can be everything. So, and I will explain you later why it's very important. It includes associated varnishing, coating, and laminating techniques. But now that's very important again. Only the following sub-processes are subject to this chapter 5 or VOC degree. So if I say chapter 5 ID, don't worry, it is the VOC degree in Serbia. So you see here A and C, because B we will speak about next week. Here you see flexography is a printing technique that is generally under the scope of the VOC degree. The laminating associated technique would be an activity under printing too. The rotogravure, that would be a printing technique under the scope, rotary screen printing and varnishing. The other two techniques that you don't find, we speak about next week. So here you see there's an overview on different printing techniques. Here you see what maybe is included or what is included under the scope of the VOC degree. And there's another issue we have to have on our eyes. There's the Annex 1 in the IED, where the number 6.7 covers surface treatment with organic solvents. That's very crucial, because if you have an installation that falls under that Annex 1, you have a so-called IPPC installation, and you have to comply with the best available techniques and so-called BIT RELs, that are best available techniques associated emission levels. So you see there are a lot of printing techniques. Of course, they are not all techniques here listed, but you see there are differences. For example, letterpress is not under the scope of here chapter 5, or sheet fed offset is not under the scope. What does it mean in practice? In practice, that means if you have an installation, you have to check exactly what type of printing you are using. For example, if you have a cold set web offset installation and one heat set web offset installation. Long time ago, under the twinning project, I have visited such an installation in Belgrade. They had exactly that combination, but it's clear for the cold set web offset, the VOC degree, we cannot apply. But of course, the heat set, web set offset would be under the scope of the VOC degree. So you see, it's so important to look exactly on the definition. And even you're using solvents, but if that technique is not listed in the scope of the VOC degree, we cannot apply for the VOC degree for that not listed technique. Even solvent or emission would take place. Another important and crucial point that very often people neglect, so you will hear probably several times from me, all the cleaning and the use of VOC containing materials, we must take into account for the solvent consumption of the printing technique. Yes, and that is very important. And there is another point, because we have to check the interface to the metal coating. In the VOC degree, you will find a remark that that you see here. That means if you have a coating activity that includes a step, a working process step, where the same article is printed by whatever printing technique. So that printing step is considered as a part of the metal or plastic coating activity, or that coating activity, whatever it is. But it is not under the activity printing. An example for that is the coating, for example, of cans. If you look for how a can is produced, you will find that they apply for the coating printing technique. But so the coating of that can, even that printing technique has been used, is not then printing, but is metal coating. Yes, so if you have a printing process as a separate activity, so that is not included in the coating activity. So you see, it's not so easy in practice to do the exact assignments. Here, if you have such a separate activity for printing in an installation, then you must look if it is a printing technique that is listed under printing on the scope of the IAD. So now some examples. First, we have a installation. Installation is a stationary technical unit where one or more VOC activities can be carried out at that site. Important is it's one operator and it's one site. So what we have to do, we have to identify the VOC activities that will be carried out on this technical unit. And for each of the VOC activities, we must determine the solvent consumption. If we have subunits, for example, if you have two heatset or two flexoprint installations as subunits, so we have add the solvents for both of them together and compared with the given solvent consumption threshold here in the VOC degree. I made here an example for you. So we have a big installation. It's the same site, the same operator. You have two printing halls. On one printing hall, you have here a heatset web offset printing unit and the flexography unit. Then in the printing hall 2, you have other rotogravure and cold set web offset printing and laminating and varnishing units. So there could be now following situations. for the heatset web offset printing, that is a individual listed activity in the VOC decree. So we must look on the solvent consumption of that activity. And if the threshold of 15 tons is exceeded, then the VOC decree will be applied. Now, there we have the flexography, and even it's in the printing hall 1. But if you look in the VOC decree, you will find flexography and other rotogravure and laminating and varnishing units if it's associated with the printing as a one category for printing. So here for flexography, laminating, and other rotogravure, we must add all the solvent consumptions and compare with the threshold for this category. That means with the 15 tons per year. But what you can see here too, you see cold set web offset. You remember, I told you that list with the categories for printing or classes of printing is exhaustive. That means is concluding. There is the cold set web offset is not listed. In other words, the VOC decree is not possible to apply for the cold set web offset printing, even you're using isopropanol and so on. But it's not under the scope. Another example. So you have two installations. It is one side, and there are no connecting parts. But it's one side and one operator. So here in that installation, you have an automatic flexo printing line, another line, and there's the one line has a lamination after the printing. So it's associated with the printing. In the installation B, you have rotogravure, and here a lamination, but separate from printing, not associated. It stands somewhere in the installation, not in line. In other words, what will be the consequences? First, we look in the categories. We see flexo printing and other rotogravure is one category. That means it's one activity. So we must consider this as one type of for printing. And now we must check now the lamination. Here it's associated because it's just in line after printing. So it is in the same category. So we must take into account the solvent consumption of that lamination after printing too. But here, where the lamination process is separate from the printing activity, here that solvent consumption is excluded. So that lamination can be another activity that we had 2 weeks before. The lamination of plastics, remember, that is an activity number 15. So that is an individual VOC activity besides the printing activity. Probably you're thinking, all is clear, it looks very easy. The reality is, from my point of experience, this differentiation or to decide what VOC activity you have is one of the most complex issues at the beginning. And so that was the reason to make you familiar. And another point we may not forget, but many people forget this. It can happen if you have a very large installation. you must check that, or may not forget that there is this number 6.7 in the Annex 1 of IED. And here you have no differentiation between printing, between coating, nothing. It is here, the activity means you treat whatever service you have, you treat it with organic solvents. And so here you must add all the maximum possible solvent consumption capacity as a total. So for example, if you have a metal coating unit and you have several printing units, and maybe you have units where you clean your products, so all of that consumption capacities, that means what is theoretically possible as a solvent consumption, you must add and compare with the given thresholds. If you exceed, but you see 200 tons per year, that is really high. If you exceed, then you have a so-called IPPC installation. That means you have to do that IPPC permitting process, and you have to comply with the best available techniques and BAT associated emission limit values. But important for you is really here for that consideration, you have no, how can I say, separate categories. That's different to this chapter 5. Here, the activity is really addressed on that service treatment and the quantities or the capacity of solvents that can be consumed for the treatment of services. So you must add all together. Now let's speak more in detail now on the requirements. So what is the scheme, how you can proceed? So first you look if you have printing activities or other activities that are listed here in the VOC decree. So you do exactly as we have done now in our examples. And if you cannot find a VOC activity in that installation, so you can be happy because the VOC decree cannot be applied. For example, for the call set, newspaper printing. But if you now have a flexo print unit, so you see, oh, it is listed, then you must check the solvent consumption, because only if you exceed the solvent threshold here, you would fall under the requirements of the VOC decree. Otherwise, for example, if you're below the threshold, you can be happy too. You have an activity, but it does not exceed the threshold, so you're not under the scope. Now we have installations that are under the scope. You heard from Elena, there are specific requirements and one of them is the obligation to substitute so-called cancerogenic, mutagenic, and toxic for reproduction substances. Here, please keep in mind, even the wording is general requirements. And you know, I think most of us, or I'm thinking, okay, I have set general requirements, but if there are specific requirements, so the specific requirements have a priority. So that's my thinking. But here it's opposite. The general requirement will apply always. The iron rule, they will apply always. So later, when we speak about the specific requirements, so the priority is different. So the general requirements have, let me say, is a higher priority because they're always to comply with, and then the specific requirements regulate the specific things. Here, please don't forget, we have in Serbia the class 1 substances. That can be toluene, that is sometimes used in printing solvents. But I heard something like an echo suddenly. I don't know why. Can somebody check if maybe the microphone is on? Okay.
Yeah, yes.
You see the yeah, here you see how the label is for this hazardous substances, and the good thing for printing is especially for food packaging printing and other printings, that hazardous materials not welcome and have been replaced, because for the food industry, very strict regulations are in place. So the emission monitoring requirements, Elena has already shown you, so I will skip a little bit the things and I come more to the details again. Now we speak about the specific requirements. Here, that is, you see there are the two alternatives. The alternative one is the compliance here with emission limit values for the stack emissions and with the fugitive emissions. And as an alternative for that combination, you can comply with the so-called reduction scheme. In easy words, that is a method where you replace and use only low VOC materials so that a waste gas abatement is not required. So you, in other words, that is something what we call primary measures, and the other alternative with is the use of a waste gas abatement. So that is the secondary end of pipe techniques. For the compliance check, you need a solvent mass balance for the emission limit values and for the reduction scheme. The echo is now again on, but now I think it's gone. Good. There is some for the very large installations that are IPPC installations. So here is a spatial topic. Such installation now have the chance to comply with a total emission limit value. I would call it like a reduction scheme value, because that value is very low, but that is possible. And so the operators can decide if they want to comply with the total emission limit value or with that combination for waste gas emissions from stacks and fugitive emissions. So that option is possible for the large installations that fall under the number 6.7 of the IED. Now, let's come to the smaller installations, because for the IED installation, there are in future different values, and that values that I show you here, they cannot be applied because the IED installations have to comply with the best available techniques conclusions, and that values are much more stricter than those you see here. Here you see the category of other printing. You see the rotogravure, fleksografia, and so on and so on. Rotary screen printing on textile, and you see, or cardboard. For example, here you see the solvent thresholds. So here that threshold is higher, 30 tons, 15 tons. Yes, so you see there are different classes. And of course, if you come to a higher solvent consumption class, the requirements will get more strict. So it's like a Champions League. If you if we have to comply with more strict requirements and the primer leak. So you see the differentiation between emission limit values for the captured and cleaned waste gases. And here the emission limit values for fugitive emissions. It's important to note that the emission limit for fugitives is a percentage of the solvent input. What you can see, so it will change. So 1 year you have another fugitive emission limit value, maybe of course the other year, because the solvent input is an annual value, and of course it will change depending from the economic situation. Here for the emission limit for the waste gas, it must be well noted that it's referred on total carbon. So that is not on VOC, but is referred on total carbon. That means, you know, organic solvent. Organic means it has carbon in its molecule, and it is this carbon skeleton. And so that limit value is referring on that, let me say, organic, total carbon skeleton of the molecule, and not on the whole molecule. The reduction scheme, maybe what is it as an alternative? So the idea was, when the solvent directive came on the market, there are a lot of existing installations. And now you have to start to reduce the amount of VOC emissions by the substitution with low or VOC-free coating or printing materials. And because the operator needs some time, and of course, such materials must be developed. So there was a target value, something like an interim benchmark. And at the end, a certain level of reduction must be achieved. And in ideal case, that reduction from where you have been started to the end is minimum what you would achieve by the application of a VOC waste gas abatement. So that is the approach and the reason why the value was named target value, because you start and that was the value that you should achieve. But please keep in mind that value target is emission limit. It has the same meaning like the emission limit value for the stack emissions. So don't be confused. It is not a value that you maybe can achieve or not, and it would have no consequences if you wouldn't achieve. No, that is a strict emission limit, and of course you must get it. Now, there is a very important point, specialty, because we do a differentiation between the emission in waste gases, in captured cleaned waste gases and captured that are not cleaned. And why we are doing it? Because the idea for the VOC directive was to reduce the VOCs for the atmosphere. So if you have no abatement and you want only comply with, for example, the emission mass concentration, what can you do? You can just put on a very strong fan, and so by the high ventilation rate, you can do a high dilution. You will waste energy, but you do no reduction. You blow just your VOCs to the atmosphere in a higher dilution. So that is the idea that we say, if you have captured stack emissions that are not cleaned, we consider it as fugitive emissions. I think that approach is very reasonable. Here you see it a little bit better what I mean. You see here that are typically fugitive emissions, emissions from doors, from openings in the installation, from the room ventilation, and so on. Here you have a machine, for example, printing apparatus. You have a abatement cleaning for the waste gases, and you have the stack emission. So that is the typical configuration. You have a cleaned stack emission. And maybe you suck off the room air, but that is a very strange case, and you would have a large installation for abatement. Then you have a cleaned stack emission too, but that is a very rare case. Here you have a machine. You extract the VOCs and discharge the VOC via stack, but without doing anything. You regulate your compliance by your ventilation system. So you understand, you would just blow up here, blow off here the materials, but you achieve nothing for the environment. That's the reason we concluded that it is here a fugitive emission. And we do that for a lot of coating and printing activities. But what does it mean? If you would have no waste gas abatement, you would have 100%, around 100%, if we neglect now the VOC in the contained waste, but you would have around 100% fugitive emissions. So you must decide what to do. You want to use low VOC materials, then the reduction scheme is the best choice, what you can do. If you say, no, my quality requirements are so high, there are no materials that I can use, then you have no other alternative as the application of a waste gas abatement. Later, when we speak about best available techniques, you will see in the printing technique, a lot of things happened, and there is a big potential to change to low VOC materials. Yes, so now how does the reduction scheme work? So the first thing is you must determine the total mass of solids of all of your printing materials. And then you just easy look in the VOC decree, and there you find the formula. Especially you see the multiplication factor. You multiply the total mass with the multiplication factor, and you calculate the so-called annual reference emission. What does it mean? It is the same as we would now work in the 1999 with classic VOC containing printing materials. So we calculate something like a starting point for our reduction work. So from that, we calculate the so-called target emission. As I told you, that's the limit value, what we must get. And for that, we use the reference emission and multiply it by the percentage. It's very easy because we just look to the table in the VOC decree, and you see, depending on the solvent consumption, it is 30 or 25%, or 25% in the special case of screen printing, rotary screen printing. And now you have compliance if your total solvent emissions that you have calculated by the solvent mass balance is the same or is equal or less than the calculated target emission. Important, you must do that calculation and the proof of verification every year, because it's an annual value and you must do it every year. You can do it in one step. For example, target emission, you use the solid, this multiplication factor, reduction factor. I have done this here for you. So you see the total factor is just here 1.2 in that case, or in that range. So you must determine the total mass and multiply it, and so you get here this limit value. Yes, so you can do this for each of the different printing that are listed under the chapter reduction scheme, because here, for example, for that textile and cardboard printing, we have different factors. So as I told you, you must calculate it every year new. And of course, measures that you have done before the VOC decree was entered into force, you cannot take into account, and it doesn't matter, because when you comply with the reduction scheme, everybody can see that you have done already something. So it's inherent included, the work that you have done before. For the solvents, for the total mass, of course, maybe you have materials that are so-called 100% coatings. That means they don't contain VOC in the printing materials. But of course, because you do something good, you can use that high quantity of solid in the calculation for the reduction scheme. So of course, that 100% materials that are VOC free will count as coating materials. And so you have the right to use that solid for the reduction scheme. If you would have solids that you recycle and you reuse in the printing, of course you can add that solids here for the calculation for the reduction scheme too, because yes, you reuse for the printing activity. Just to add, but it is not so relevant for the printing installations. For installations, or to simplify the application of a reduction scheme, it is possible for smaller installations. Here, for this number 3 installations or activities, to verify your reduction scheme, if you use materials, as you see here, printing inks, varnishes, adhesives, and so on, that have individual, that is for each of them, not as an average, but each of them a solvent content of less than 10%. So in other words, if you use materials with less than 10%, you can just use this simplified verification. That means you write to the authority and say, I confirm that I am only using here such low VOC containing materials, and I comply with the reduction scheme. So that is one way for simplification. Yes, organic solvents. I think here you can look later on the more detailed information, but it's important to note it must be organic and it must be volatile. Volatile means it must have a vapor pressure of 0.01 kilopascal, at 20 degrees Celsius. And very important, this addition of the sentence, that volatility under the particular conditions of use. In other words, for example, if you do a heating process and you have a solvent that is maybe under normal conditions, not so volatile, but maybe in the drying conditions, such material would then be an organic volatile solvent. The solvent definition is very exhaustive because it is not only the classic meaning. It includes dispersion media, viscosity adjuster, and so on, plasticizers. So it is a very large, comprehensive definition that includes a lot of functions of solvents. Yes, here you find some examples about the volatility and so on the solvents. Now let's check what solvents are used here in the printing units. So in the packaging flexography, very common is ethyl acetate, ethanol, isopropanol, and so on. And for cleaning, of course, according to the principle, same solves same, or equal solves equal. Here you use then cleaning agents like ethyl acetate, ethanol, isopropanol. For rotary screen printing, there is a larger variety of solvents. You see white spirit, solvent naphtha, xylene, and so on, solvents that can be applied. And in lamination and varnishing, that is more equal to the flexo printing units. That is ethanol, ethyl acetate, and methyl ethyl ketone, MEK. Yes, the concentration for the classic solvent, you see about 60 to 70% can be solvents. And here are some other examples of a water-based, for example, printing unit. You see a high content of water, but that is very often neglected by some people. Water-based doesn't mean it's only water. Of course, you have in water-based paintings or printing units, printing materials, you have VOCs too. So like here, alcohol, like here, 1 to 50%. Here again, the obligation for printing unit. So you must do that first the identification, then you have to register and substitution of CMR. You must then decide if you want to comply with the emission limit values or the reduction scheme. And of course, the compliance check you must do by the annual solvent mass balance. Now, we come to the part to familiarize a little bit on the application techniques. So you see flexography and non-publication rotography printing materials we see every day. That is, for example, here some from packaging printing. So on many of products, we see, of course, that printing. And so the materials are paper, plastic, aluminium, or compounds. So here you see an example of a large packaging printing unit. And as I told you before, there are water-based and solvent-based color systems applied. Of course, if you use organic solvents, then you, in most cases, you need to apply always gas abatement technique. So yes, this we have already done. So here you see now example of a flexography printing unit. Import here, maybe you see the best. You see here this flexo plate. Here you see you have the ink tray, the doctor plate that takes away the excess ink. Here you have this Anilox roller, and from that Anilox roller, the print code is then transferred to that flexo plate. And here now the printing process between this flexo plate and here it takes place. Here you see the transfer between the Anilox and here's this plate cylinder, where here the color or the paint is then transferred to the flexo plate. Here you see some nice YouTube links where you can get a better maybe picture on the printing techniques for those who are not so familiar with it. Another picture of here a central impression cylinder with here color stations, but they have the same, let me say, construction. And finally, here in all the printed material is feed to the dryer. And of course, you have the VOC emissions from the dryer and during the application. Yes, another impression of a modern machine, how it's working with a central cylinder. Yes, so you see that's very important. You see here in the same time best available techniques. You see here a closed printing paint station, and you see the tubes, so everything is closed, so you avoid a lot of fugitive emissions by that closed paint station. Here a scheme again on such a flexoprint unit, a very large one. You see here the impression cylinder and the dryer here. And of course, you can have here a lot of additional units like laminations, or such a printing line can be rather large with a lot of extra additional technical units. Now, rotogravure, it's a different printing technique. So the printing area, so you have a cylindrical image carrier, and the printing area is below the non-printing area. And yes, you have here the doctor plate that takes away the excess print too. And here the impression roll, the substrate, whatever it is. And the link is here after the doctor plate only remaining on the engraved areas. That's the reason it's called rotogravure. So here you see another YouTube link for where you can see it more in detail. That is now a packaging gravure scheme. The technique is always the same. You see here that ink tank, and here's the pump. What you can see already here, very good. If, for example, that is open, you have solvent losses. So that is a source for fugitive emissions. Here in that ink tray, of course, it's the same. You can have here losses of VOCs because you have here the ink, and here you transfer the ink to here this substrate. And of course, yeah, here you see a little bit, it may be nice. You see here this, yes, this saucers, or yeah, with color, and here that bars or are elevations that have no color, because here you have this doctor plate, and the printing process takes in place, as you can see. Yes, so there are some examples. Another techniques is the rotary screen printing. That is rather simple. You have a screen, and you pass the ink here through the pores of this image carrier. So that's the reason it's called here rotary screen printing. Important is here only the web feed printing is under the scope and not the sheet. So you see that is rather important to understand. Not all printing activities that are existing will fall under the scope of the VOC directive, only that are listed. And so it must be a web that is printed by that rotary screen machine. The lamination, you know, that is a technique where you make a composite material based on multiple layers, so at least two. So you glue two layers, webs, together. And a lot of flexible packaging products, of course, are laminated. And so very often the lamination takes place directly in line or associated with the printing activity. But if not, if you, for example, produce a laminate before you print by separate machines, that means it is not an associated print activity that we have to count to the category printing, but it's a different VOC activity. So that about that lamination, we have reported the last training, you remember. Here is an example. You have here the printing unit, and it is not stopping here after the printing. You see here it goes to an adhesive applicator, where adhesive is applied on the layers on the web. And then here you have the lamination process. Here that takes place here. And at the end, you have here this laminated product. But you see, that unit for lamination is directly associated with the printing. Now, about the emissions. You see here, of course, during the printing, we have the VOC emissions. And we have emissions, for example, for the cleaning of the equipment. And of course, we can have emissions for the paint, or yes, for the ink manufacturing or preparation, when the printing inks are mixed or made ready for applications. So here you see, for example, for flexography and gravure printing installations, the process steps. So you see the ink supply, so that is of course relevant for VOCs. The printing itself, of course. You have interim cleaning. During the drying, you have VOC emissions. And maybe during the inline finishing, like lamination, you have additional emissions. So an example, you have paper, you put in and you get out something, print a product. You have the VOC input by the inks, and you have VOCs by the use of cleaning materials and of course thinners for the printing ink. And here you have then the different way out for the VOCs. For example, those that have been captured and have been cleaned, those that are fugitives, and you have VOCs mainly here, for example, in distillation sludge or in waste. That means waste inks, waste cleaners, and so on. But you see, most part will result from the collection of the waste gas from the printing machine and with the dryers. So that is a rather clear picture, because you always try to get and collect all VOC emissions and to feed it to a waste gas abatement. Yeah. So the situation can be like you have here, for example, the dryer and the printing unit that is maybe closed, and you extract the VOC gases from the application zones of the printing machine. And together you put it to this waste gas abatement, like a thermal oxidizer or other oxidative technique, like regenerative thermal oxidizer. And maybe you have some remaining outlets where VOC can get out, but they are not cleaned. What can it be? It can be, for example, here from the room, the printing room, or it can be for elder machines, the application zone. Sometimes in elder machines, only the dryer are extracted and feed to the waste gas abatement, but not the application zone. So that can be from the application zone. But do you remember all that stack emissions that are not cleaned, we have to consider as fugitive emissions. Yes. So the solvent mass balance. It is a how can I say? It's a core element of the VOC decree. It means it's a first, of course, monitoring tool to check that what you put in as VOC solvents, of course, must get out somewhere. And like the name says, balance means input means it's the same like output. Of course, first it is a verification tool. It is a compliance check, but it is more. For those of you that are among us as operators, I can understand that maybe in a first reaction you think, oh, that makes me troubles, that will cost a lot of work and I have no benefit. but that's not true. If you understand that sys-solver mass balance is something like a management tool for you that will help you to improve your processes, to find out where you have, let me say, where you can improve the efficiency of your work, where you can save materials, and that means you can save resources and money, then you will find the benefit of such a solvent mass balance. So it is, the solvent mass balance is clear from my point of view, a good tool to help you, and you should not consider it as something that you must do because you must do, but it is something that is really in your interest. So in other words, you should spend effort to establish that tool for your installation, and one time if you have established, I'm sure you will not miss it anyway. So, but of course we need that tool anyway to check if we have a compliance with fugitive emissions and with the reduction scheme, if it is applied or if it has been chosen. So for those operators now who start to comply with the new requirements, the best is you need a team, and of course you need a responsible person in that team. Important is that the team has access to all of the, let me say, other operation unit teams, because they must first identify the VOC activities that you have, and then they must collect data on the applied materials. After the data collection has been done, you must analyze the data, and for sure you can assume that you will have lacking information, so you must contact your suppliers and manufacturers, especially to get information on the VOC content and on the content of solids. Then you can make a picture of the situation of your installation. And if you find out that when you elaborate a solvent mass balance, maybe you find out that you have no compliance, you can then use that as a chance to think for the future. What approach do you want to do? Do you want to go more on maybe more modern products, more that are with low VOCs, for example, infrared or UV techniques? Or do you prefer to stay what you're already doing, the work with solvents? Then maybe you need to buy a waste gas abatement technique, probably a waste gas incinerator. And you see, that is a working process. One time it has been established, you will have to do it always, but the work will be easier. So the first time when you start, that's the hardest time, but after that it is routine and it will help you. So now that picture for some of you as operators probably that could confuse you, but don't worry, it is not so complicated as it looks in the first view. So what you see here are the different inputs and outputs. So it's clear that what you purchased and what you put in, it's clear. It's called input I1, and that is a quantity here purchased and used from, for example, 1st January of a year to end of the year, 31st of December. Maybe you have a recovery like a distillation in your installation, in your waste gas. You have a maybe active carbon filter or something, and you can recover the solvent. And if you use it again for the same activity, so the next Friday, we speak about such an installation where toluene is recovered. So that's a typical classic example by the application of active carbon filters. So, and if you use that recovered material, then that is called I2 in that time period. But if you store it, then, or you use it for another VOC activity, then that is called O8. Here you see the different output. If you apply a waste gas abatement based on thermal oxidation, you will destroy, of course, the VOCs. And so that quantity that you destroy, that is called O5. And then you have O11 left over. That is that waste gas that has been cleaned and discharged by a stack to the atmosphere. That one you know already. That is if you discharge the waste gas only without cleaning by a stack. So that is O1.2, but that we consider as a fugitive emission. Here you have then output, the output of O6. That is not a fugitive term. It is that VOC that is collected in closed containers, and you normally use a specialist or waste company for the disposal for the hazardous waste materials. Here you have O7, but that O7 you see in products that you sell. Normally, that is relevant for pharmaceutical products or paints production, but not so much for printing units. There can be some special cases. So this is for next Friday, where maybe you recover toluene from your waste gas by your active carbon filters, and then you sell by yourself that recovered toluene to other companies as a solvent. That can happen. Then for sure it's O7, but normally you don't have O7, you have O3. O3 is a fugitive term. It is that quantity that will remain maybe in your printed products or laminated products. Yes, so that is something of VOCs that will be evaporated during the time when you store it. So that is fugitive. Here, you know, 204, that are all the emissions that are fugitive, like from windows, openings, and so on. Yes, there's another one, O2, that is VOC that will be discharged in the wastewater. But normally for the printing sector, that should not be a large quantity or not relevant for in most cases. So I can tell you the most relevant parts for the printing sector is this I1. And then if you use a recovery, I2, but generally if you don't have a recovery, so it's 0. But important if you work with a waste gas abatement, because you want to stay on VOC containing materials. So that quantity of 5 is second important quantity, and O6. O11 is relevant for the calculation of 5, but from considering the quantity, of course, O1 will be a small quantity, because the most parts you want to destroy. So yes, maybe here you see the term when we would determine the fugitive emissions in a direct, that means additive way. So if you would add now all fugitive O's here together, I would not recommend to do that. I recommend the indirect method. I will show you. Here for the printing installation, so you see again, you have the dryer, you feed to the RTO. Here I made an example where this printing presses, so it's an old machine, where the printing brushes are here collected, but VOC waste gas is discharged here without any cleaning. So that is a fugitive value. So the key quantity, remember, I told you, was the solvent consumption. The solvent consumption is annual fluctuation. And so we must calculate it. And the calculation is done by the solvent input of materials that you have purchased in that year and applied for the activity, minus 0.8. That means that what you have here recovered, but in your installation, and not external, but in your installation, and you have stored or used for another activity. So the solvent consumption is over 1 year. And of course, for the calculation, you must keep in mind that yes, that this solvent term is very comprehensive and not only classic. And you may not forget the volatility of solvents under particular conditions of use. In other words, if you have a dryer, you have to take into account the volatility under the drying conditions. How can you do this? You just need now, that makes probably the most work. You need a register. The best would be an electronic register where you where you list all the purchased materials that used for the printing activity. So you must determine the annual input quantity. Very often you know only the volume, and then you need the density to calculate the kilograms per year. You need how much is in the printing materials that you're using. For example, if you use a thinner, then it's 100%, of course, organic solvents. So now from each of the materials that you're using, you need to determine the annual quantity and have to calculate the VOC content. It's not possible that, for example, you have a term like printing inks, and then you do an average. For example, you say, oh, I have 20 tons of printing inks, and I make now 70% solvent, and that's it. No, you must do it. You must get the information on each material that you use for the printing process. You have to list it, and at the end you can do yes, something like a conclusion. But you need to list really every material that you're using for the different printing recipes, and you have to do that list really for all materials that you're using. I know it can be a very hard work. Some large printing units have big Excel sheets or big yeah, it's very comprehensive, and it takes time to establish such input system. Here's an example. So you have a specific material. So you have to list all the used materials you need when you start. So 1st January, and you do the inventory and what you have purchased, and the end of the inventory, then you know what you have used, and you know here the mass of contents of VOC, but then you need the density, and you can calculate the quantity. Yeah, so you see how it could work. You do the calculation, just you start, you know what you have in your stock, plus what you have purchased, and you know what you have at the end in your storage, and so you can calculate this I1 as input. So here's the recipe how to proceed. You must register all the materials. You must check the VOC content of all the materials. That means you have to ask for the safety data sheets. You have to check to the VOC contents and solid contents. Then you can calculate such a list for the solvent input. And if you have solvent recovery and you store the materials or use it for another activity, then you must determine that flow, because then you can take it account as O8, and it will not help you much. It helps you only if you are very close to the threshold, and then maybe you can, if you subtract O8, you can be not under the scope of the VOC decree, or maybe you can come to the class with less strict requirements. But yes, so, but generally the recovery of solvent is not so common, but for some printing installation it's relevant. Yes, so for the solvent input, you should take care a lot, because that is the most crucial quantity. I mean, it's clear. So in worst case, all of the solvents that you have purchased and used will be emitted. So it's clear the solvent input is the most important quantity. So that determination must be very precise. So you should take a lot of care and effort to get a reliable calculation of the solvent input. And there are, as I told you, there are some tricks. I mean, there are some possibilities maybe to fail. So here it is necessary to spend time. Here's an example from a data sheet. For example, here FlexoSolve, that is for the flexo printing, for washing. And so you check now, and you see very often this label for the flame gives you an indicator that you have a VOC material. You check then in the data sheet, for example, the vapor pressure. So you see it is exceeded the threshold of 0.01 kilopascal. And you see too, from the data sheets, and here safety data sheet, you see it's 100% solvent because it's a cleaner. Then you must check this H statement, because remember now why. If you will find hazardous substances like the CMR substances, So you remember the CMR substance, you must substitute it in shortest possible time. But maybe you will find Serbian class 1 substances. And if you find Serbian class 1 substance, please remember too that emission limit value of 20 milligrams for the stack emissions you have to comply with for such materials. So for example, if you find toluene, you know, it's a Serbian class 1. So for that stuff, you need to comply with 20 milligrams. That input I2 can be important. Why? That could be a test question. It is important because if you have such a solvent recovery, remember the limit value for the fugitive emissions, how it is calculated. It's calculated by a percentage to the total solvent input, and the total solvent input is I1 plus I2. So that's the reason if you have a recovery, I2 is important. Here you see again the possibilities. You have that your printing activity. You have here that internal solvent recovery, so your distillation. And here you cover it and you can use it again, clear. Or you use it for another activity, clear, it's O8 because you don't use it here. Other activity means not other same printing line. It means really another different type of VOC activity. Or you store it because you didn't use it, it's O8. If you sell it maybe, then it's O7. If you collect it, and because you cannot use it, although you have distillated it, then it's O6. Yes, so for 011, for example, that is, you remember what is here in the outline as a clean waste gas. According to the quantity, it will have a low relevance, but maybe for the calculation of O5, it can be relevant. How can you calculate it? You calculate it from the concentration that you measure, but please, now some people do often mistakes. Here, because maybe some people are thinking, oh, we take the worst case, and so they use the maximum measured value, but that's not correct. You should use the medium measured value, and the same here for the waste gas volume. You should not use the maximum measured waste gas volume, you should use the medium value. And here it's very important, you need the operation time of the waste gas cleaning during the VOC times where VOC emission processes have been taking place. In other words, for example, it can happen, you have a thermal oxidizer and you start in the morning, maybe 5 o'clock, but the operation of the printing takes place maybe at 7 o'clock. So in that 2 hours, you have no destruction of VOCs, because it is just to make the this waste gas abatement hot and ready for the operation. So here you can only take into account, of course, the time where the VOC abatement has been worked and VOC process have been taking place at the same time. I will explain you why here it's important to use these medium values. 0.1.2, it is normally a medium relevance, but it is not necessary to determine it. It makes no sense. Why? Because the direct approach of fugitive emissions, it is so complex and you make so many mistakes because you cannot determine the values very good. You have failures during the measurements and so on. So the precision or the accuracy is not so high as if you would the indirect method. So here you can save effort and time if you use the indirect method for the determination of fugitives. Now, 05, that is the second most important quantity for printing installations if you use organic solvents. Here, that quantity or how much is destroyed is crucial, and there are different options to do. One option is that you calculate it by the efficiency of your waste gas abatement by this formula. And this efficiency, maybe you can start by the information that the manufacturer has given to you, but it's better to do the determination during the official emission measurements. So you need crude gas and clean gas measurement at the same time. So you can calculate that abatement efficiency. And that together with the measured values, you can calculate 05. You will see examples now. 06 is that quantity that is collected in the waste, and you know there are European waste classifications, and generally the VOC containing waste is a hazardous waste. Here are some typical examples. For example, here the different EU waste classifications for printing. And 07 is normally not relevant for, I think, most cases for you. 08 is here, as I told you, normally not relevant. But here, please keep aware. Some people think that if they dispose the VOC containing waste to external waste companies, and where maybe the VOC then is recycled, they would consider that as not as 06 but as 08. But that's wrong, because in such waste specialist waste companies, they mix the waste and there's no control anymore. So for us, we consider only recycled materials as 08 if it has been done by a distillation unit that is a part of the VOC activity. So not if the VOC waste has been recycled by an external company. There can be some certain cases where we can accept it, but that are really so few and special cases where it's clear that this company is working only for the printing unit or for the automotive sector. Now to the fugitives. There are two ways, as I told you already. This is the indirect way that I recommend. So we start from what we put in minus that sources that are not fugitives. So that is here 011, 05, 06, and 07 if it's applied, and 08. Or the alternative could be we determine all the fugitives outputs and add it together. So, but you can see that value I can determine very high, in a high precision. That one is possible too, but here the determination by measurement is very complex and normally will fail always. I can tell you from my experience. So here you see the same formula, but I made here a special trick. You see, I have just put here a bracket to the both terms, and I see 011 plus 05. It's in one bracket. In other words, what is it? That's the cleaned waste gas, and that has been destroyed. So it's clear. That's the quantity of the crude gas. So that is what how the quantity of the crude gas that we put in. The calculation for the fugitive emissions, we need that percentage of I1 and I2. And for the reduction scheme, we need to calculate the total emissions. The total emissions, it's clear that, of course, must be fugitive plus stack emissions. So that are the total emissions. So that is relevant for the reduction scheme. If we want to calculate the total emissions, so we just add now 011 plus 011. So at the end, we get this formula. Okay, so I think here you find additional information. Maybe it's not necessary to go through to everything because I explained already most things. I want to go what is more important. Yes. To this compliance check. So you see that are the relevant quantities for our emission monitoring, where we have to do the solvent mass balance. The first is to determine the solvent consumption. You see, we need the calculation of this input minus 0.8 if we have a recovery. Then, of course, we have to check the stack emission limit value. This we can do by the emission measurement report, otherwise it's not possible. And then we have to do the compliance check with fugitive emission limit values or total emission with limit when we apply the reduction scheme. Now, there come some problems. I will go or just to that presentation. That maybe here I can explain you why there are problems. So if you apply now a waste gas abatement and you want to comply with stack emission limit values and the fugitive emission limit values. And for the fugitive emission limit values, if you use this indirect method, you can see what quantities have an influence on the fugitive emissions. So it's clear. If, for example, if you use a too high 011, that means that one you make a wrong determination, overestimation of the cleaned waste gas, then that will cause that your 0.5, what you have destroyed, will increase up if the abatement efficiency is the same. But what will happen if you rise up 0.5? Then of course you subtract it from I1. It means your fugitive emission will less, and probably maybe you can comply with the limit value. But in reality, it can be different. If so, you see why I told you, if you use here the highest measured values, you will rise up 011. Of course, you will rise up 05. And of course, you will lower the fugitive emissions. But maybe that's not the case. So you must use and apply here realistic values. Then I recommend to use here the measured mean values. Now, how to to calculate it. You can use you need to, if you want to calculate it by the destruction efficiency, if you know it, and if you have this, you can use that formula. But you see, you need then to calculate 011. 011 has some problems for the calculation, because why? You measure 011 by a so-called FID, flame ionization detector, and you get as measured value the total carbon. But we need normally the substance, and so 011 we have to calculate. That means, remember, that was here, you find the formula here. That's the formula for 011. You need the volume flow, you need the time of operation for the waste gas, and during emission relevant processes have been carried out. And you need what's called a factor, like a response factor, a conversion factor, including the so-called response factor, to convert from the carbon skeleton to the substance, to the molecule weight. So, you know, if you have a mixture, it's very complicated. So you need that calculation. But coming back to that one, even you calculate this as total carbon and not convert this as a substance, then you do a worst case approach, because 011 will be smaller as in reality. That means you subtract it from I1. That means this fugitive emissions, what you calculate, will rise up. So it's conservative. Even you do then the calculation with as total carbon for 05, it's the same. 05 will be less than it is, because in reality you don't have this carbon, you have the whole molecule, and so it's conservative. But one thing you keep in mind too, we have a combustion process, and during the combustion the composition of the crude gas will change. So in the clean gas you will have probably different molecules as what you have in the crude gas. The crude gas, you have the classical molecules from the solvents, but in the clean gas maybe you have a different composition of VOCs. So here are some examples on the influence. From time reasons, I think it's unnecessary. I think the most crucial point I have made you sensitive. What I recommend is here the solution. If you want to be, if you operate a waste gas abatement and you want to be on the safe side and you want to avoid conflicts with the authorities, the best solution is to implement a continuous measurement on the total carbon in the crude gas. That means before the waste gas abatement. because, as I told you, here you see, if you determine the crude gas, the concentration of the crude gas, you measure the total of this here in the bracket. And so you can just subtract it from I1, and you can subtract 0.6, and then you have it. And the other thing is, you need, of course, a volume flow meter, and you need the time of operation of the waste gas abatement in combination with your solvent and your consuming processes. And normally, you know, the main relevant substances as solvents, and you can calculate a representative response factor or conversion factor for this. So that is, I think, the most accurate method. But if it's not possible because it costs too much money or it's too complicated, then probably you have to determine that you must do the way I have shown you before. You must calculate here 0.5 by that method, and that means you must determine the efficiency of the waste gas abatement regularly. So during the normal measurements, you must do then parallel measurements for the clean gas and the crude gas, and you compare it, and then you know what was the efficiency. So if you do this every 3 years or every year, I don't know, then you can be, maybe that can be useful and give you that necessary information. So here an example now. Typical printing installation. We have here no waste gas abatement, and it's clear by using solvents we have no compliance, because okay, you can turn out the fan here on, and you can maybe do a big dilution and you can comply, but it is not possible because that uncleaned stack emissions we count as fugitive emissions. So you will not comply with fugitive emissions anyway. Here you see typical fugitive emissions here too. So compliance is not given with stack emission values and fugitive emission limit values. So we must install a waste gas abatement, or we must do a reduction by substitution with low VOC materials. So here the operator decided to install a waste gas abatement, and now it's important, you see, I made it here with blue, to collect really all VOC sources that otherwise would be fugitive. In other words, you must try really to collect all fugitive sources, and you must include them in the waste gas cleaning, here thermal oxidizing. Otherwise, you would have further on problems with fugitive emissions. Second alternative, you start the substitution process. So here, I did the calculation. We have the solvent input. We know the solids in the colors. And then we can just simple do this calculation. You remember, it is really very stupid and really simple. You just look in the table, you see, oh, I have to calculate by 4. And you know, here's a reference emission. And from that, you do the target emission. And you see, you must have 35 tons at the end. Now, here's an example. We replace now 75% by water-based colors, and they have only 20% VOC. Here, the different materials. We have no waste gas abatement. And when we do the calculation, and we must, if we assume the same quantity of solid, that's important, that we assume the same quantity of solid. So that we know we must have only 35 tons as a VOC emission. So we can see that by the substitution that I proposed here, we can achieve compliance. Here's another study that you get a better picture in how it works in practice. It's a packaging printing unit. And so that is what you start. You must establish a data system for all the applied materials that you use for that printing process, for that printing activity is the right wording. And you must do it for each identified VOC activity. In other words, again, if you have that laminator that is separate from your printing unit, so you have two VOC activities in your installations, and you must do for both that solvent mass balances and so on and so on. So you cannot mix it. Some people, because it's complicated things, they can mix it. No, it's not possible. You must do what I show you here as an example for each of the identified VOC activities. And you must demonstrate compliance, of course, for each of them. So here you see the ink, thinner, cleaning agents, inputs, and so on and so on. Here we have a recovery. So you see, we have here 88 tons that are recovered, but they are an input I2. That is the quantity of the solids. Here are the quantity of the waste. So you see that's the waste. And finally, we have here 210. According to the waste, to remember, the quantity of the waste, quantity of the waste, we subtract from the solvent input when we use the indirect method. Here's the same. If you overestimate the waste, VOC content in the waste, then of course you would simulate maybe compliance with fugitive emissions, but maybe that compliance is not given. So here it can be important that you must do analysis, or you must make a reliable determination of the VOC content in the waste. Yes, now we do the calculations, and we can see now when we do the compliance check, here is no compliance. So when we compare, for example, with the BIT ILs that are now published, we see we will not comply to. So that is an example about the use and the control of VOC printing installations. That solvent mass balance must be done annually. And I want to say, because it's funny again. Even today, I had a talk with one of our environmental engineers from local authorities, and he has sent me a So a mass balance about a printing unit, same like here we are speaking now. And the operator was using just only an Excel file. I mean, that Excel file is a useful tool as to give a summary and to help the operator at the end to show the compliance. But that Excel sheet, because of the aggregated data, is not sufficient. For the inspection work, that's in the normal work of the inspectors, like me, the soil mass balance is more. I have to check if all the data are reliable that the operator has here included. For example, if there's a number of the solvent input, I have shown you, there can be maybe 30 recipes for printing. And so I must check if all the 30 recipes have been correctly taken into account. And I must check about the ranges. Some operators are always using maybe ranges or not accurate values. So you see, for example, the check for hazardous substance, it's the same. I have to look on the safety data sheets. In other words, the Excel sheet is something like an abstract. It is like, for me, like, yes, a first impression if I have a problem or not. But the real compliance check is then done during the inspection work, because for the inspection, all of the given data must be proved somehow. By spot controls, doesn't matter, but somehow I must see if these aggregated data are reliable or not. So, but now, what are maybe the best options? Again, it's my personal opinion. If it's possible to replace the VOCs, then please do it. Nowadays, you will find so many nice printing and lamination techniques based on low VOC materials where you have a compliance without any abatement. I recommend to you that. But I know generally in printing sector, this will depend on the machinery you have. If you have old machines, but they are still working maybe, or on your personal situation, for example, if the owner is elder and maybe he wants to give up the installation, of course, it makes no sense to invest maybe money in very high tech things. Then maybe it's better you try to switch to voice gas abatement technique. But one thing is clear: for the compliance with the VOC decree, you must do something. Nothing doing it would be the wrong approach. It would cannot be accepted. So you must do something. But the decision is up to you as operator. If you decide for voice gas for voice gas abatement, then you should try before to avoid all sources that are fugitives, and maybe to can improve your housekeeping. So in other words, you should try finally to keep your voice gas abatement as small as possible. So it is better to try to optimize maybe the emission sources to, if it's possible, to prevent them or to improve the situation. It's better, because as less volume you feed to the waste gas abatement, as less your operation cost will be, and less the cost for the abatement unit will be too. So here you find a lot of best available techniques here, based now on primary measures like radiation, curd, varnishes and inks and so on. Here that you have, later you can check if you like, or you go directly to this document. Here is an example, just that you believe me, where an operator, that this company is using water-based flexoprinting materials here for its installation. Or an example for UV printing. Here you see that's a UV printing unit without any abetment. I mean, that is available. And it's not only that companies that are offering such machineries. You have printing materials based on UV, and you have yes, this machinery and paints. So there can be a lot of other things done, as I told you, automatic dosing, closing, the paint supply, improving in the mixing, and so on. But this you find here. I think it makes sense to repeat it. Here you see now the BAT-IL for the large industrial emission directive, Annex 1 installations. You see that is the limit, the total emission limit value that is based on the VOCs on the kilograms of solid. So you see it's something like a reduction scheme. The value is very low. Yeah, and here you see as an alternative the combination between stack emission and fugitive emission. You see here the value for the fugitive emission is very low, 12%. And yes, and you see 20 milligram, that is the upper level, that is the limit value we have here in Germany for thermal oxidizers. That are the BAT-IL were derived from submitted data in EU from a EU information exchange, and you see here the normal thermal oxidizers are working very good. So in most cases they are below 20 milligram. Yeah, here is an example of a 3-tower thermal oxidizer. You need a 3-tower minimum, because if you have only a 2-tower, you have a peak during the switching between the towers, and that is what is not best technique. So you have a 3-tower as minimum solution for as best available technique for thermal, for regenerative oxidizer. Here inside you have you have here inside ceramic bodies. They are heated up and store the heat, and they heat up then the crude gas when it's coming in, and here in the upper zone, because it's so hot, the first cracking processes and destruction processes will start. So there are other options, especially for printing. Here you see something for the dryer, a smart dryer for printing, because you do circulation system, and only a small part of the circulated air is then discharged to the waste gas abatement. That has the reason it has a very high VOC concentration, so that you can achieve autothermic incineration. That means it's not necessary to feed natural gas as an additional auxiliary fuel to the abatement technique. I think such smart methods are very important nowadays, especially in the times where we are living now in the moment. Yes, here's another picture of such a waste gas recirculation line to really to concentrate the VOC in the pipe that you discharge to the waste gas abatement. Here you see a little bit better, maybe. So you see that line is then feed to the abatement, but then very high concentrated. So the combustion efficiency is very good. Here is an example of a printing unit with lamination and extrusion unit, and all are here collected and feed to a RTO. Not to forget to improve the cleaning of parts. Here you have normally another high VOC emission source, and here you have different options to improve for improvement by, for example, using water-based materials. And if you use VOC materials, it should be closed, and you can connect that to a waste gas abatement. Here are some examples of very modern and efficient cleaning machines. I think some of you as operators, you know the company. It's very famous here in Germany, Firma Renzmann. They have very smart solutions for, I would say, almost every printing, cleaning devices, for small parts, for large rollers, and so on. So they are really specialists for environmental solutions. But of course, there are other companies. I don't want to be misunderstood. Of course, here we do training, and for the training to show you what is possible, I use just an example. I could have chosen another example, but I have chosen now Renzmann because here I find these nice pictures, and so I wanted to show you this. But of course, there are other companies offering similar systems, and it's always up to you as operator or what else, what you want to apply. But important is that it should be closed. For us, for the environment, for environmental inspection, it is important that you work according to the best available technique and not in an open way where the VOC can evaporate into your working room. Here you see that the smart way, the dirt material here is coming in. Here you have this cleaning, and then afterwards it is feed to the distillation. It's feed again, so it's refreshed and cleaned. And here, that waste gas you feed to your large, let me say, central abatement unit. So that can be a smart approach. Here's an example how it is realized. Yes. But maybe what is much better and for us preferable, if you use not VOCs, maybe you can use high-tech cleaning agents based on water solutions. And if you use here water, so normally there should be no waste gas abatement, because by water it's not necessary. So that can be a closed apparatus. Yes, so you see that is an example of such a water based application, and here you have no emissions. Here is an example when you use a low or a cleaner that is not under the scope of the VOC decree because of the low VOC content. Yeah, so you see, you can get a good result, but of course it takes some time and maybe some work and effort to identify what is the best cleaning agent for your purpose, and that is not maybe under the VOC decree.